right, we're going to talk about similarity in right triangles now. Okay, so theorem 7-3, the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. So here's our right triangle here. Okay, so I have A, B, C. If I drop this altitude from my right angle down to my hypotenuse here, what's going to happen is A, B, C, and A, C, B are similar, and C, D, B are similar. So we have three triangles that are all similar there. This gets kind of tough, kind of visually trying to look at picking out which one is which. A lot of times we have to mirror it on one of the angles there. Okay, so triangle ACB is similar to triangle CCDB, and it's similar to triangle ADC. Okay. Identifying similar triangles. What similarity statement can you write relating the three triangles in the diagram? Okay. All right. So the first one is, a lot of times it's easiest to start with the largest triangle, right? Start with the big triangle out here. Okay, so I'm going to start with the triangle, and I'm just going to go P, Q, R. So I went P, so here's P. I then went to my right angle, and then I went to R. Okay? Now, if I want to go similar, I'm going to go triangle, and let's look at this little one, because I'm going to use P here, because I started with P, so I know P is equal to P. So I'm going to go to this triangle right here, so I know I start with P. Well, on the first one, I went to the right angle. So the right angle here is going to be S, and then Q. And I'm going to say that that is similar to. Now this is where it gets a little bit trickier. I know that S has to be in the middle, okay? And if we look here, I'm going to go Q, S, R. So this little sliver matches up with here. So this angle here is going to match up with R. So we should have R on the ends. So if I look at my first one and my last one, I have R on the ends here. So that would help you match those up. Right. The geometric mean. All right. So the geometric mean of A and B is the positive number such that A over X equals X over B. It gives us the same ratio. All right. So find the geometric mean between 6 and 15. So what we're going to do is we're going to go 6 over X equals X over 15. I'm now going to cross multiply. So this one up here, you could go X squared equals AB. So X squared equals 6 times 15. So X squared equals 90. Or I'm going to square root that. X equals the square root of 90, which is going to give me, so 90 does not have a very nice square root. I'm going to break that up into 9 and 10. We know the square root of 9 is 3, so this gives me 3 square roots of 10. There's my answer. Okay. 2 and 8, so let's do 2 and 8. So I have 2 over X equals X over 8. Okay, erase this one here. This one might hopefully is a little bit nicer. So we're going to cross multiply. X squared equals 2 times 8. X squared equals 16. Well, that's nice because we know the square root of 16 is 4. Okay? Could be plus or minus. We're usually talking about links here, so we're going to use the positive side. Okay? So there's the geometric mean between 2 and 8. Okay? So corollary to 7.3, so it's kind of an extension. The length of the altitude to the hypotenuse of the right triangle is the geometric mean of the lengths of the segments of the hypotenuse. Okay? So what that is saying is, here I have my altitude here. It breaks this up into two pieces. So I have X over H equals H over Y, or H equals the square root of the product of these. Okay? So this is a very important piece here when we're looking at solving for this height and these pieces here. Okay? Corollary 2, the altitude of the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the hypotenuse and the length of the segment the hypotenuse adjacent to it. Okay? So this is kind of hard to see here, but I've separated this hypotenuse into x and y. So if I go x over this leg 1, so it's red here, so leg 1 equals leg 1 over the whole hypotenuse. Okay? And the same thing goes for y. So y over leg 2 is equal to leg 2 over the whole hypotenuse, AB. Okay? And the reason is because we're actually looking at similar pieces. So if I look at, well, let's look at this one here. So if I look at x here on the small triangle, x is one of the legs, right? Well, it matches up with this leg. So it's saying that this is similar. And then when I go to the leg 1 of the small triangle here, that's the hypotenuse over the hypotenuse. So this is just matching up pieces of similar triangles. So now we're going to use the corollaries to find x, y, or x. I don't know where y and z are. That's fine. Okay. So we're going to use it to find x here. Okay. So I have 4 over 8 equals 8 over x. There's my piece there. So now I'm going to cross multiply. 4x equals 64. I'm going to divide by 4. X equals 16. There's my value for x. Okay. So now I have, here's my x. I need to now find my whole piece here. So I'm going to go x over 20 equals 20 over x plus 9. Okay. So this is going to give me x squared plus 9x equals 400. X squared plus 9x minus 400 equals 0. Okay. Well, I know 20 times 20, but that's not going to give me 9. Let's see, 25. So I have 40 times 10. I have 25. Might have to plug this into the quadratic formula just to make it quicker. So I'm going to go negative 9 plus or minus the square root of 81 minus 4 times 1 times 400 all over 2. Okay? So 4 times 400 plus 81. Okay, so this whole thing right here is going to give me negative 9 plus or minus the square root. Actually, the square root of 1681 over 2. This is negative 9 plus or minus 41 over 2. So if I do the negative, that's going to give me a negative value. I can't have a negative value here. So I have negative 9 plus 41 over 2. That gives me 32 over 2, which is 16. So this value right here is 16. Okay? So it probably does factor. That's okay. We use the quadratic formula. Why wouldn't they let the butterfly into the dance? Well, because it was a mothball. All right. What happened when the chicken slept under the car? He woke up oily the next morning. All right. So that's using right triangles and geometric mean to find the separate pieces.